we go? Did we finish, I didn't make a note of where we stopped. Did we stop after number 5?
Yeah.
So we haven't done 4 or 5? All right, then let's start with 4. And words are getting kind of bad again. Okay, so what I would like you to do, and remember, the purpose of practice is to give you different strategies to use when you sit down and face a problem on your own. So I'd like you to think about number 4 like this. So in other words, I've written it sideways instead of up and down. You'll see why this might be helpful in a minute. Now, what is cotangent? What do you know about cotangent? It's reciprocal of tangent. Reciprocal of tangent. What's tangent on your little paper here? What's tangent? Sine over cosine. Look where I'm pointing on my paper. It says tangent is sine over cosine. So what would cotangent be? Cosine over sine? Now, what is cosecant? Cosecant is reciprocal of sine, so it is 1 divided by sine. I don't think that's on this half sheet, that was on your orange sheet. We talked about that. Cosecant is reciprocal of sine. Now, I've got a fraction divided by a fraction. How do I do that? Keep, change, flip. So I'm going to keep this, change that to a times, and flip this. Now what happens? Look at that. What's going to happen? The signs are going to cancel, and what are we going to be left with? All that's left is cosine over 1, or just cosine. Number 5 is the same. I'm going to write it sideways, and I changed the thetas to x's because I don't want the theta to scare you. It's just a variable. So if you don't want to use theta, you can make it an x or some other letter. Now, what's cosecant? We just talked about it. Cosecant is 1 over sine. And what about secant? What is secant? 1 over cosine. So now I'm right back to where I was a second ago. I have a fraction divided by a fraction. So that will be key, change to a times, and flip. Nothing's going to cancel. So I'm just going to multiply. So it looks like I have cosine over sine, which is what we just talked about it. If tangent is sine over cosine, then cosine over sine is cotangent. So the simplified answer is cotangent. I know we talked about this a little bit the other day in terms of secant squared and tangent squared. But on your little reference sheet, the big main identity says sine squared plus cosine squared is 1, right? We've used that one, okay? That identity sometimes looks just like that, but it can also be written like this. Now look at that. Does that make sense to you? That would be the same thing? All I did was subtract the cosine squared over to the other side. Or I could have subtracted the sine squared over to the other side, and it would look like this. So sine squared plus cosine squared is 1. Subtract this from both sides and you get this. Subtract this from both sides and you get this. Those are all the same identity. But depending on the problem, it might behoove you to look at it in one way rather than the others. So let's look at problem number 6. On the top, I have a cosine squared. On the bottom, I have a 1 minus sign. Now, be careful. These identities, everything has to be squared. These only work if things are squared. So there isn't anything you can do with the bottom. But what do we know about cosine squared? What does cosine squared equal? 1 minus sine squared? So I'm going to write that as 1 minus sine squared. They are not the same thing, so you can't cancel them. You cannot cancel part of the numerator or part of the denominator. It's all or nothing, unless you factor. This actually factors. Does anybody know how that factors? 1 minus sine squared? It's the difference of squares. So that numerator is going to factor as 1 minus sine, 1 plus sine. Just like kids, a squared minus b squared is a minus b, a plus b. Remember that? The difference of squares? So 1 is a square, sine squared is a square, so 1 minus sine, 1 plus sine. Now what do you notice? Now I can cancel that whole parentheses, that whole denominator. And what am I left with? 1 plus sine. 1 plus sine. That's your simplification right there. Okay. Well, now we only have 14 absent. Okay, number 7. Where are we looking? Wow. Any ideas? What's tangent? What's tangent equal? Sine over cosine. So I'm going to write this as sine over 1 times sine over cosine plus cosine over 1. So I'll just think of everything as a bunch of fractions. Sine and cosine are like the simplest elements. They don't break down, sine and cosine. But everything else does. Tangent can break down into sine over cosine. Okay? Now, can these be multiplied? This is a multiply right here. Yeah. What do I get when I multiply these two together? Sine squared, yep, over cosine. Sine times sine over 1 times cosine. Now these are not multiplied, these are added. Don't try to cancel. We can only cancel if it's a multiplication. These are being added. What do I need to do if I'm adding? Common denominator. And what will my common denominator be? Cosine. This one already has it. This one needs it. So I'm going to give this one a cosine. Remember, if you put it in the bottom, you have to put it in the top, right? Now, they both have the same denominator. They both have cosine. So there I go. I'm going to write one fraction now. Cosine in the bottom. What's on top? Well, this one's sine squared. Plus, what's this? Oh my gosh! We're jumping for joy. What is sine squared plus cosine squared? 1. So now I have 1 over cosine. Well, wait a minute. What's 1 over cosine? What's the reciprocal of cosine? Secant. Yeah. The answer to the problem is secant. So who would have imagined that that original problem would boil all the way down and just be secant? Quit shaking your head. This is the coolest thing ever, Bo. Come on. All right, looks like number 8 is very similar. Let's try number 8. And let's use the same procedure that we just did. All right? So look at this first part right here. Is cotangent breakdownable? Can we rewrite cotangent? Yep. What is cotangent? Cosine over sine.
Like, where are you finding this? How do you know that? This on the green sheet?
Okay, well, we have already talked about this, Bo, twice now. Okay, once today, once last time. Right up here, it says tangent is sine over cosine.
Yep.
Cotangent is the reciprocal of tangent. So tangent will be cotangent will be cosine over sine.
Okay. Makes sense. Thank you.
With sines and cosines, we don't change them. There's nothing to change them into. They don't break down. So I'll just write that as sine over 1. All right, what's tangent? Sine over cosine. Cosine doesn't break down, so I'll just write it cosine over 1. You don't have to put these guys over 1, but it's easier for me because I'm going to be multiplying them. And it's easier because I'm going to multiply straight across. Oh, wait a minute. What happens here? This is a multiplication. What happens right here when I multiply these? Don't the signs cancel? So this just ends up being cosine. What about these guys right here? And that just ends up being sine. Now, don't get excited. They're not squared. And if they're going to be 1, like they were over here, if they're going to be 1, they have to be squared. Sine plus cosine is nothing. So that's the answer. That's as far as we can go with it. Okay? Remember, those identities over here that we've been using only work if we're squared. All right. Any ideas? Okay, so let's make sure we're clear on this. You have to do something. You can't just sit there and stare at the problem. So would distributing be an option?
Yep.
Yeah. There's a better option. 1 plus tangent squared. Look on your paper.
Change it to sine over cos.
I could, absolutely, that's another idea. But on my paper, 1 plus tangent squared is secant squared. Now, guys, listen. When you did proofs in geometry, the idea was you ended up in the right spot. It didn't matter. Some kids would do the proof in 3 steps. Some would do it in 23 steps. It didn't matter as long as you ultimately ended up where you were going. The quickest way to get to the end is to recognize that that right there is on your sheet and it's secant squared. Now, if you said to me, tan squared is sine squared over cosine squared, you're exactly right. And you'll eventually get the right answer. It's just going to take a whole bunch more steps. If you distribute, that's okay too, but again, you're going to have a whole bunch more steps to go through to get to the end. But they're both perfectly okay. They're acceptable. What do I know about secant squared? This is a multiplication problem. What do I know about secant squared? What is secant? Secant is the reciprocal of the cosine. So I'm going to change that into 1 over cosine squared. And since this is a multiplication problem, what is going to happen? One of these is going to cancel, right? And I'm going to be left with 1 over the other one, 1 over cosine, which is secant.
Why do we want to?
Because you only have 1 on the top. You have 1 on the top and 2 on the bottom.
Was that cosine squared?
It was squared, but when I canceled, I lost one of them. It's like if you have a over a squared, you can't cancel both out, right? You can only cancel out 1. All right, what was that? 9. All right, let's look at 10. I hope it doesn't surprise you when I write number 10 like this, because I did that with a couple of problems at the beginning of the period. Now let's see if you were paying attention. What do I need to do next? All right, what am I gonna do next?
So you're gonna use
What?
sine over cosine?
Exactly. Good. I'm gonna change this into sine squared over cosine squared. And what am I gonna do with secant squared? I'm gonna change it into, that would kind of be going backwards though. What is secant? Secant is the reciprocal of the cosine. So I'm gonna change this into 1 over cosine squared. Now what am I going to do? Keep change flip. So I have sine squared over cosine squared times cosine squared over 1. What happens? We can cancel these guys, right? So what are we left with? Sine squared. And that's your answer. Sine.
So you don't have to put it over what?
You can.
Okay.
You don't have to, but you can. The only reason I put things over 1, Willow, is because when I multiply fractions, it's top times top, bottom times bottom. So I like to have a top and a bottom for each piece. But you don't have to do that. All right, sine squared, secant squared. This one actually does have several different ways you can start it. So tell me what occurs to you and we'll just go with it. What do you notice when you look at this problem? Do you notice anything? I got some squares, and as soon as you have squares, you can start looking at these squared identities here.
This secant goes to 1 plus tangent squared.
Okay, so, yes, Cam, what if though, I might save myself a little bit of work, what if I factored out a sine squared? So since these both have a sine squared, if I pull that out, I'm gonna be left with secant squared minus 1. Now look on your paper, what, secant squared minus 1 is something. What's secant squared minus 1? Tan squared. Tangent squared. So we have sine squared times tangent squared. Any thought on that? Well, there really isn't much I can do with this. I could change tangent squared into sine squared over cosine squared, because that's what tangent is on my paper, sine over cosine. But nothing is going to cancel, would you agree? And in fact, what am I going to be left with on the top? Sine to the 4th over cosine squared. And that's about all we can do, guys. It really doesn't, nothing cancels out further. That's what we're left with. Okay, here's a good one. Here is a good one. I want you to look at the top of that fraction. And tell me if you notice anything about it. You won't see it on the paper because there aren't any 4s on the paper, okay? But just look at it. What do you notice about cosine squared minus 4? It's the difference of squares. And how will it factor then? Cosine minus 2 cosine plus 2. Guys, we gotta get used to, x squared minus 4. Everybody in this room had better know how to factor this or it's hopeless, right? That's the difference of squares. You've got to get past the fact that this has a cosine in it, because it's exactly the same thing. Cosine minus 2, cosine plus 2. And what's the beauty of that? Yeah, as soon as you factor, you can cancel, and your answer is cosine x plus 2. That's it. Number 13.
You're here too. Oh, you're here too. Okay,
I did not leave myself much room here because this is about a two-stepper.
two-step.
One plus.
Okay, so Cam is thinking along the right lines. He is paying attention, he's focused, and he says secant squared is 1 plus tangent squared. Absolutely correct. How about in that same list of identities there, what's 1 minus sine squared? I had it written on the board at the beginning of the period. If you didn't write it down, I don't know what to do. 1 minus sine squared is the same as cosine squared. All right, I'm gonna do it one more time. And then guys, you gotta help yourselves out. Yes, it's hard, but yeah, you're gonna have to be able to do it. And you have to do everything you can to help yourself. What happens if I subtract this sine squared from both sides? What does that equation now say if I subtract sine squared from both sides? Cosine squared equals 1 minus sine squared. So, what is 1 minus sine squared? Cosine squared. So now I have secant squared times cosine squared. What's secant? 1 over cosine. So this is 1 over cosine squared times cosine squared over 1. What happens when you multiply those? It all cancels and you end up with 1. Ooh. Yep.
Shorty.
Gotta just keep paying attention and hammering it out here. Cosecant tangent plus secant. All right. Wow, that's a mess. Let's change it all into sines and cosines. What is cosecant? 1 over sine. What is tangent? Sine over cosine. And what is secant? 1 over cosine. All right, so let's look at this really carefully and make sure we're all clear that the first 2 parts of that problem are times, but the last part of that problem is plus. We can cancel whenever we're multiplying, okay? So, does anything here cancel? Those. So we're left with 1 over cosine plus 1 over cosine. Right? We can combine them. Don't they have the same denominator? So that's going to be 2 over cosine. It's like having 1/5 plus 1/5. Wouldn't that be 2/5? So we have 2 over cosine, which is 2 secant. Now, if that is a stretch for you, back up. Isn't 1 over cosine, isn't this secant? And this is secant. So we have 2 secants as our answer. 2 times 1 over cosine. 2 secants. So look at that original problem, really lots of stuff going on. What did I do there? I changed everything into sines and cosines, and then things canceled, and it worked out okay. All right, which one was that? So we're ready for 15. All right, so we have sine squared, secant squared, minus sine squared. Well, there's always more than one way to do this, but something just occurred to me. What is cosecant squared? Cosecant is the reciprocal of the sine. So this guy right here could be 1 over sine squared. Would you agree with me? Well, what happens when I multiply sine squared times 1 over sine squared? It all cancels, so this just equals 1. And then I still have my minus sine squared. That's cosine squared. Bingo, done. See how fast that was? See how easy that was? All right. Who's got an idea? Who's got an idea? No one has a single idea.
I do, but I don't think it's right.
Well, go ahead and say it.
It'll be like 2 different signs and plus cosine.
Yeah, doesn't this mean sine plus cosine times sine plus cosine? And that's a FOIL, isn't it? A FOIL. So sine times sine is sine squared. Sine cosine. Cosine sine. And what am I left with? Cosine squared. Okay, well, we're supposed to be simplifying. That got kind of big there. You may notice anything. My little heart's pumping fast. Because I see something pretty big in there. What's that and that? What happens with those two? They make one. They make one. And then these two do not cancel out. I'm adding them. But would you agree they're like terms? Sine times cosine is the same as cosine times sine. So one of them and one of them is going to make 2 of them. And that's your answer. One more. Oops.
Yeah, you got it. You know,
All right. right, what do you think?
Isn't it just another foil?
What?
Don't you foil it?
Foil, absolutely, we'll foil, so first times first. Outsides. Insides. Glass. Okay, we're kinda like where we were with this last one, we have a lot. Do we notice anything? Cross out the middle. Aren't these the same, only one's positive and one's negative? It's not like over here where they were both positive. Here I have one positive and one negative, so they're gone. So now I have cotangent squared minus cosecant squared. Now I want you to look on your sheet, and you have an identity that says 1 plus cotangent squared equals cosecant squared, right? It's in the same area. Yeah, and can we move things around? Absolutely. So, you can, if you want, you can look at that identity that's on your paper and say, what happens if I rearrange some things? Or you can simply say, what is cosecant squared? Cosecant squared, right here, is 1 plus cotangent squared. So when I'm subtracting this cosecant squared, I'm really subtracting 1 plus cotangent squared, because that's what it equals. Right? Now let's distribute the negatives. So cotangent squared minus 1 minus cotangent squared. Oh my gosh, what does that just come out to be? Negative 1. That's negative 1. That one works out to be just negative 1. All right, let's get out our extra practice sheet. I gave you an extra practice packet. It's got some practice quizzes in it and some other things. So you will need to do these on another sheet of paper. Obviously, I didn't leave enough room. So go ahead and get out a sheet of paper. And we're going to do these in a little bit different order than how they are in the paper. I'm going to skip around a little bit. So I'm on my extra practice sheet. You're going to do this on a sheet of notebook paper. And we're going to start with number 2. All right? So we've done enough of these, you might have an idea. What do you think about this problem? What might be a good way to start? Very good, Abby's got this. She says change cotangent into cosine over sine. And it's a multiplication problem, so I'm gonna make it sine over 1. And what's going to happen? Signs are going to cancel, and the answer to the problem is just cosine. Now let's skip down to number 4. It is very similar, only a little bigger. Anybody have an idea how we would start this one? What's cosecant? 1 over sine. Now, cosine, we don't change. So it stays as cosine over 1. But what about tangent? Sine over cosine. Now, all that is multiplication. So any tops cancel with any bottoms. So sine, oh my gosh, the answer is 1. Number 6. Come on, you can do it. Sine over cosine times cosine over 1. What happens? Cosines cancel, and the answer to the problem is just sine. Number 8. Come on, same kind of problem. What are we gonna do first? What's secant? Oh, secant is 1 over cosine. How about cotangent? Cosine over sine. And then sine is just sine, so we're gonna leave that sine squared. We're on problem number 8. Cosines cancel. And one of the sines will cancel. So that one will cancel with one of those, and the answer is sine. Wow, look at number 9. Tan, cotan, sine, secant. Whew, here we go. Tangent, sine over cosine. Cotangent, cosine over sine. Now, remember, we don't change signs. So that's just gonna be sine over 1. And then secant, 1 over cosine. It's all multiplied. So any top can cancel with any bottom. So let's see, we got cosines are gone, sines are gone. None of that cancels. So we're gonna be left with sine over cosine, which is tangent. All right, number 12. This one's a little different because it looks like it has a plus sign in it, but we're gonna approach it pretty much the same way. So what's the first thing you're gonna do? Sine over cosine. This time plus cosine over sine. Now, guys, you gotta pay attention. You're not going to be canceling in this problem. You understand that? You can only cancel in a times. This is a plus. So what do we do in a plus? Get a common denominator. And what will our common denominator be? Sine, cosine. So this one needs a sine. And this one needs a cosine. And now do they have the same denominator? Which is sine, cosine. And then what do I have on the top? That's my denominator, sine times cosine. What do I have on the top? Sine squared plus cosine squared, which is 1. All right, number 13.
Shit, 36.
13, yeah.
Yeah, let's practice.
I know I'm skipping around, but I'm trying to do all the problems that are alike. Then we'll come back and pick up the other ones. What's tangent squared? What's tangent? Sine over cosine. So sine squared over cosine squared. What's cosecant? 1 over sine. Now this is a times problem. So do I need a common denominator? No, I'm allowed to just cancel. So it looks like I am left with 1 over cosine squared, and I know that 1 over cosine is secant, so my answer is secant squared. Oh my gosh, look at number 14. You got it. What are you gonna do with sine? Nothing. You're gonna write it down. Sine over 1. What are you gonna do with cosine? Nothing. Cosine over 1. What are you gonna do with tangent? What's tangent? Sine over cosine. And what are you gonna do with cotangent? Cosine over
Miss Ford, what's up with the X? Why do you always have to put the X? You don't really say that. It's just like sine and then cosine.
But it's, you can't have sine without an angle. You have to have an angle attached to it. So X is the angle.
Oh, okay.
Like if you just typed on your calculator sine and pressed enter, it would not give you an answer. It has to have an angle attached to it. Okay, what do you notice? All times, this is gonna be gone completely. And all we have left then is this out here, which is just sine times cosine. Oh my gosh, it gets worse. Look at number 18. Sine, cosine, tangent, cotangent, secant. Okay, it's just like the one we just did. What sine? What do I do with sine? Guys, you can't do anything with sine. Sine doesn't break down, it doesn't rewrite. So since this is all multiply, I'm just gonna write sine over 1. Same with cosine. But tangent is sine over cosine. And cotangent, cosine over sine. And secant, 1 over cosine. I could make this 20 terms long, it doesn't matter, you just go through and write down what each one is. And then, hopefully, things will cancel. So that will cancel, that will cancel, and that will cancel. So that one is just sin x. Yep, all you have left is a sign, yep. All right, one more, number 19. All right, so here we go. Can't do anything with a sign. But what about a secant? What's secant? 1 over cosine. It is not squared, it's just 1 over cosine. What about cotangent? Cosine over sine, and that one is squared, so it'll be cosine squared over sine squared. What do we notice? Those cancel, right? And one of these will cancel, which leaves me with cosine. Ooh, that's a lot, isn't it? A lot. Okay, I'm not gonna assign your homework till next time, but feel free if you wanna get started on it. I'm not assigning it till next time. We're gonna spend a little bit more time practicing.